Okay, so for this first bit, you can skip this part if you were not here when we did that. That makes a little bit more sense in class, so you can skip these. But what we are generally talking about is this middle, the midpoint, the spot right in the center of a segment, and we call that the midpoint. And sometimes we call it a bisector. And the difference is the midpoint is a point, and a bisector is a line, ray, or segment intersecting at the midpoint, right? So you'll see the difference here. This is just a point, so we call that a midpoint, where this one also has a midpoint, which we generally call M. But we also have this line here, this line that intersects at M. So the line, that line DC, is a bisector. So the technical definition of a midpoint. So the midpoint is the point on the segment that divides it into two equal parts. So we know that if M is the midpoint, then I'll be able to say that this segment here, AM, is congruent to this segment here, MB. If that is true, then M is the midpoint, right? Because it'll divide it into two equal parts. And the same thing with a bisector. Bisector is the line that intersects at the midpoint. So anytime you see the word midpoint or bisector, you pretty much know that you're going to be dealing with, so if DC is a bisector, if DC bisects AB, then we know that AM, right, this distance here from A to M, is going to be congruent to the distance from M to B. And pretty much any time you see these two words, bisector or midpoint, you know you're going to be dealing with two equal parts, that the two parts that you have highlighted are going to be congruent to one another. So let's look at a few problems. So we're going to skip a page and go to this extra practice. And let's take a look at these problems. So identify the bisector of AB. So AB is this one here, from the distance from A to B. And we've got a midpoint here at M, right? And I know it's a midpoint because AM is congruent to MB. And if AM is 13, then MB must also be 13, right? So 13 plus 13, AB is going to be equal to 26. So take a minute and see if you can do 2 and 3, just like we just did. So if I know that AM is 8, what does MB have to be? It's also going to be 8, right? Because I know that AM is congruent to MB, right? So I'd say AM is congruent to MB, and if AM is 8, then MB also has to be 8, which means AB is just going to be 8 plus 8. So AB is going to be 16. And the last one, I know AM is congruent to MB, and I know that because they tell us, they give us these two little notches. I also know that this is a midpoint because of that. So if MB is equal to 26, then AM must also be equal to 26. And 26 plus 26, that means AB is going to equal 52. Okay, now let's try these last three problems here, 4, 5, and 6. These are the ones we did as a class. So let's take a look at number 4. So I know I've got a bisector here, right, from M to T, right? And I know that it's a bisector because I've got two equal parts on either side, and they tell me they're congruent. So I know that EM is going to be congruent to MF, right? EM, this distance here, is congruent to MF, which is that distance there. So let's plug in what we know. We know EM is equal to 6x, so I'll put 6x. And I know MF is equal to 2x plus 4. So I know that those two things are equal to one another. So now I just got to solve for x. So we're going to start by subtracting 2x from both sides. Oops. X. So then 2x minus 2x cancels out, leaves us with 4 equals, and then 6x minus 2x is 4x. If we divide both sides by 4, we get x equals 1. Now, it doesn't say for us to solve x. They need us to find the length of EF. So we're finding the length from E to F. And this is the step that everyone in class had trouble with. Now that I know x, I need to substitute x in for x. So if this is 6 times x, and I know x is 1, then I'm going to say 6 times 1 is 6. So EM is going to be 6. And if EM is 6, then MF is also going to be 6. And that makes sense. 2 times 1 is 2, plus 4 is 6. So EF is going to be just 6 plus 6, EM plus MF. Right? Which is 12. So try 5 and 6 in the same way. I know that it's a little tight, but see if you can find it in the same way. So I know EM is going to be congruent to MF, right? They tell us that this is congruent to this. So let's plug in what we know. We know EM is x plus 15, and we know MF is 7x minus 3. And we know those things are equal to one another. So now we are going to solve for x. So we're going to subtract x on both sides. So we get 15 equals 6x minus 3. So then we're going to add 3 to both sides. Finish this up here, and we get 18 equals 6x, right? 15 plus 3 is 18. And then we divide both sides by 6, and we get x equals 3. Now we're not done. Now that I know that x is 3, I'm going to take my x, and I'm going to plug it in for x, right? I'm going to take that 3. If I know x is 3, and I'm going to plug it in for x. So this is going to be 3 plus 15, which is 18. And if I know that these are congruent, if this is 18, then MF also has to be 18. So EF total is going to be 18 plus 18, right? EF is going to be 18 plus 18. That's EM plus MF. So EF, the distance from E to F, is going to be 36. Let's try one more problem here. So if we know that EM is congruent to MF, then we can plug in what we know. And we know that because they tell us so, right, that those are congruent. So I know EM is equal to 3x minus 4. And MF is equal to 5x minus 12. So now I'm going to subtract 3x from both sides. And we get negative 4 equals 5x minus 3x is 2x minus 12. Then I'm going to add 12 to both sides. And I get, we're going to finish this up here. Negative 4 plus 12 is positive 8 equals 2x. Divide both sides by 2. And we get x equals 4. So now I'm going to take this, and if I know that x is 4, I'm going to plug it in for x, right? So if I know that EM equals 3x minus 4, right? That's 3 times 4 minus 4. So 3 times 4 is 12, minus 4 is 8. So EM, the distance from E to M, is going to be, this is going to be 8. And if this is 8, then MF is 8, which means EF, our final answer, to do it over here, EF would be equal to 16, right? 8 plus 8 is 16. So what I want you to do is I want you to try these problems down at the bottom, 1, 2, 3, and 4, just like we just did. And then we will try this next part. All right, so welcome to part 2 of Notes 2.3. So if we look at this number line, look at how many dimensions is this number line, right? We can only go right and left, so that is a one-dimensional, that is just one dimension. So let's find the midpoint between two numbers. If I gave you 0 and 10, what would be the midpoint? So I would go, okay, well, 0 to 10, that is a distance of 10, right? So 10 divided by 2 is going to be 5, right? So I could count 5 from one of the endpoints. 1, 2, 3, 4, 5. So my midpoint would be there, and I should have 5 on the other side too. 1, 2, 3, 4, 5, right? So if I wanted to find the midpoint between negative 7 and, let's say, 3, right? So negative 7 to 3, that is a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. Okay, so we also have a distance of 10, and 10 divided by 2 again, right? If we're dividing that distance in half, we get 5. So I could go 5 from each endpoint. 1, 2, 3, 4, 5. So my midpoint is going to be at negative 2, right? And let's just do one more. So if I wanted to find the distance between 6 and 8, right, I've got a distance of 2. So 2 divided by 2 is 1. So I would have 1 away, so my midpoint would be at 7, right? So what if we got a really large number? What if I needed to find the midpoint between like 3 and 4,261? I can't sit and count a bunch of squares on a number line. So we need a more sophisticated method of figuring this out. So what we can actually do is we can actually add the two numbers together and divide by 2. So if I add 0 plus 10 and divide by 2, 0 plus 10 is 10, divided by 2 is 5, which we got as our midpoint. If I add, say, negative 7 plus 3 divided by 2, negative 7 plus 3 is negative 4, divided by 2 gives us negative 2, which we found as our midpoint for that one. If I add 6 plus 8 and divide it by 2, I get 14 divided by 2, which is 7, which is what we found the midpoint to be. So anytime I'm looking for the midpoint, I can just add the 2 points together and divide by 2. So now let's think about this in 2 dimensions. So how would I do this in 2 dimensions? Well, we would do the exact same, use the same method, but we do it twice, once for each dimension. So if I want to find the midpoint between negative 4, 8 and positive 4, negative 2, right? So negative 4, positive 8 would be here. And positive 4, negative 2 is here. And I want to find the midpoint. So I should be looking, right, if I had to turn this into a segment, I'm looking for something in this zone here, right? That's going to be its midpoint. So we're going to look at the x dimension first. And I'm going to say, okay, well, why don't we take my difference in x's. So I'd say I'd take one of my x coordinates plus the other x coordinate and divide it by 2, right? And we would get our midpoint this way. Then we would do it again for the y. So I'd take my y coordinate plus the other y coordinate and divide it by 2. And then we would get the difference this way, right? So between both dimensions, we would land at our midpoint. So let's plug in what we know. So let's call this x1, y1, x2, y2. So my x1 is negative 4, and my x2 is positive 4. We're going to add those together and divide by 2. Then we're going to do it for the y dimension. So my y1 is 8. And my y2 is negative 2. And we're going to add those together and divide by 2. So negative 4 plus 4 is 0, divided by 2. And 8 plus negative 2 is 6, divided by 2. So 0 divided by 2 is 0, and 6 divided by 2 is 3. So our midpoint is going to be at 0, 3. So I would say, okay, well, 0, 3 is right there, and that's our midpoint. And that looks about right. That should be about midway through. So the midpoint formula is this: x1 plus x2 divided by 2, then y1 plus y2 divided by 2. And that is the midpoint formula. So let's try a couple of these problems. We can skip 10, 11, and 12. We can skip these problems. And we can look at this here. So I've got my midpoint formula. So m equals x1 plus x2 divided by 2. And y1 plus y2 divided by 2. So let's label my points. So we've got x1, y1, x2, y2. And so my x1 is negative 4, and my x2 is 0 divided by 2. And my y1 is 3, and my y2 is 5. So I'm going to add them together and divide by 2. So negative 4 plus 0 is negative 4. And 3 plus 5 is 8. Negative 4 divided by 2 is negative 2. And 8 divided by 2 is 4. So our midpoint is going to be negative 2, 4. And we can skip 8 and 9 here as well. Let's just jump to the last page here. So I want you to find the midpoint between these points here. So for this first one, you would identify the points. So that first point is at negative 4, 2. And our second point is at 0, 0. That's kind of easy. And then we're going to label our points x1, y1, x2, y2. And then we would put them into our midpoint formula. So x1 plus x2 divided by 2. And y1 plus y2 divided by 2. So then we're going to plug these in. So my x1 is negative 4. x2 is 0 divided by 2. y1 is 2. y2 is 0 divided by 2. And then negative 4 plus 0 is negative 4 divided by 2. 2 plus 0 is 2 divided by 2. So simplify and we get our midpoint equals negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. So that would be our midpoint. So negative 2, positive 1 right there. So finish the rest of these problems. You only got 2, 3, and 4 to do, and that is the end of 2.3.